Good evening, everyone. I hope you're having a lovely week. I hope you're warm wherever you are, even with the cold. And it's good to hear you guys again this Thursday. So I'll go ahead and just introduce our topic for today. So we'll be doing an introduction to Android. And I think it goes without saying that Android is something as a tech, as an IT professional, you'll interact with at some point of your career. And with us to just introduce the topic and get the idea into our minds is Kiiru Maina, who is an alumni of Cyber Shuja. He's also currently working at Equity Bank as a product security architect. He's had experience working with development teams, specifically in DevSecOps. He's also have had experience in application security, cloud security, and just to go on and on. So he'll start us off on this topic on Android, and we should be able to build an idea on what that would look like. So karibu sana Kiiru, and welcome to the session.
Hello, thank you so much, Hope. Yes, Hope. Good evening, and thank you very much. I hope there is no echo on my end, and you can hear me clearly.
Yes, you are audible and clear.
Okay, thank you. So as Hope has said, my name is Kiiru. I'll start off with a disclaimer. So I am also learning. So I am learning by teaching. What's it called? I'm trying to reinforce my learning by having this particular session. So I hope we all benefit from one another, and the questions that you ask, if I'm not able to answer, I will research and get back to you, probably through Hope or through the Cyber Shuja forums that I'm in at this particular point in time. So I think that being said, we can proceed. Just give me a moment. Let me share my screen.
And some people just don't even have the strength to pray. And so we have to intercede on behalf of our neighbors because we are called to love them and take on their burdens as if they were our own. So I just pray that this blesses you guys and remember.
Okay, thank you very much. So kindly confirm that you're able to see my screen.
It is visible.
Okay, good. So we can proceed. So today, like Hope has said, I'm going to take you through an introduction to Android and touch just a little bit on security. So this is going to be a very introductory session, so you can relax. So today we're going to do Android, just an overview of the Android architecture, the fundamentals of Android security. This is very many. I'm just scratching the surface. So we're going to do fundamentals of storage, because that is where all our data is stored, because we have so much data stored on our Android devices, and cryptographic APIs, because that determines how exactly our data is stored. So with that being said, we can proceed. So we'll start with the Android operating system architecture. But before we get there, I'd like to believe that we know Android was developed by Google in the early 2000s, and the first devices started on Android started running in about 2008, 2009. So since then, Android was open sourced, and this made it possible for developers and manufacturers in the greater mobile phone space, television space, and so on and so forth, be able to adopt Android as their operating systems on their mobile phones. So this led to more innovation, and unfortunately led to the collapse of Nokia. That was one of the many reasons why Nokia collapsed, because they were not able to innovate, but that's a story for another day. So we've had the Android operating system generally has evolved over time. So I think the time we were having iOS phones here, that was Android 3. Yeah, because I remember my first Android phone was Android 4.4. Yeah, so that was yeah, that was some time back. So now we've been able to move. I think right now we're in Android 15, 16. You can confirm that later. So what is this Android? The Android operating system is now not only on just mobile phones. We have it on our televisions. We have it on almost any smart device that is there, because this is because Android is open source and any manufacturer can take it, tweak it to their liking, and they're able to use it. So so now that we have said all that, what is composed of the Android? How is the Android operating system built or layered? So we'll start with basically an overview. So Android is Linux based, so it has it's built on a layered architecture, which is broken down into 4. So you have the Linux kernel, the hardware abstraction layer, then you have the Android runtime and native libraries, and then you have the application framework, and then you have the applications on the top. So so each of these layers play a specific role in enabling a mobile application functionality, and they're built to ensure that every single the layers are designed in a way that they're very modular, so you can separate all of them almost on an individual component, and this brings about some aspect of abstraction and also a greater extent security. So the first layer is usually the kernel. So the kernel is usually at the bottom. So this is the foundation, and this is what connects the software to the hardware by abstracting the components of the hardware, and manages the processes, the device drivers, your device's security, and your manages your memory, amongst many other things. So this Linux kernel is the same as the foundational Linux library, but it's built on Linux libraries, but it's customized to run on a mobile phone, because a mobile phone is an arguably a small piece of hardware that you use on your that might not sustain very huge loads of you can't run a server on a mobile phone. Basically, that's what I want to say. So this is customized in a way that it's supposed to fit your mobile phone. So yes, and then the second layer is the hardware abstraction layer. So the hardware abstraction layer is the bridge between the kernel and the other layers. So between the native libraries and Android runtime, the application framework, and the application layer. So why does this act as a bridge? So it acts as a bridge because it allows your device manufacturers, this is your Samsung, Techno, who else? Oppo, uh, yeah, Samsung, Transsion, Oppo, and the likes to, and also you, if you want to develop an Android phone to interact with the applications, hardwares, such as your camera, your GPS, your sensors, Bluetooth, and so on and so forth. So you as a manufacturer, you're able to plug in your own device drivers that are able to communicate with the hardware of your mobile phone. So it's basically what brings your phone, one of the components, one of the very key components that brings your phone to life. So the other layer is we've said the native libraries and the Android runtime usually run on the same, usually runs on the same, usually in the same layer. So the Android runtime is what defines, uh, makes your phone to work. So this is this usually has a virtual machine. So there is usually a, before it used to run on a virtual machine called Dalvik, that is on Android 4 going backwards. From Android 5 it replaced it with Android 5. Reason why it was replaced with Android 5 is because there's there are different ways applications are compiled. So you have just-in-time compilation, then you have ahead of time compilation, and finally you have a combination of the two. So just give me a moment. Are you able to hear me? I'm fixing my mic. Kindly confirm that you're able to hear me.
Loud and
Yes, you're
clear.
audible. You're audible.
Okay, good. So uh, so we have just in time, ahead of time, and profile guided compilation. So just in time compilation is how do I explain it in an easy way? I'll explain it to you basically how I understood. So I download an app from Android store. Let's call it from Play Store. So let's call it App Y. So this App Y is written in, say, Java. The problem is my mobile phone might not understand Java directly, so it has to convert it to binary. So for that, you need to you need to compile your application into code that the machine can run. So there there are ways in which there are two ways. So you have the just-in-time compilation, three ways: just-in-time compilation, ahead of time compilation, conversion, and profile guided compilation. So the just-in-time compilation is when the application is installed quickly and the code is compiled while the application is running, and it's fast to install. But when you're using the application, it's a bit too slow because it's compiling as you use the application. So when you open your messages, you need to, what's it called? Your application takes some time because it needs to like run in the background um, and then display to you your messages because it's translating the code. Oh, sorry. Let's assume Y is a messaging application. So that is just-in-time compilation. And then you have ahead of time compilation. So this is where the application is compiled before it runs. So when you're downloading this particular application, it might take a bit of time because that is when the compilation is happening. So this is when you've already downloaded all the data, and then when you're on Play Store, it tells you installing, but then there's nothing being done. So that is when the compilation happens. So this might increase the time you take before using that particular application, but that makes the application run faster and use less battery on your phone because it's already running. What's it called? It's already running. It's already compiled, so it doesn't compile when you're using the application. So it makes the whole process more. What's it called? It makes the whole process easier. So what makes the ahead of time compilation possible is the Android runtime. So that's I look at Android runtime like preparing a meal before you're hungry so that you can eat it immediately when you're hungry. So the reason why this is important, Android runtime is important, is because it makes it possible to have the ahead of time compilation makes it possible for you to have a faster application startup. You have better performance and you have less battery usage. However, it will take up more storage because you have compiled your application into native code. So your application is likely to be bigger, and also it's going to take longer to install because it has to compile fast. So mhm. So yes, so now let's talk about profile guided compilation. So based on what we have said, this just in time has its own inefficiencies. It takes more power. It 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 takes more power, more battery power. So it reduces your battery life, and it makes your application slow in cases where speed is of essence and performance is of essence. So the problem with ahead of time and then the problem with ahead of time compilation, it takes a longer time to install. So and then it takes up more storage. So how can we balance these two, the inefficiencies of these two systems? So we have profile guided compilation. So profile guided compilation comes in and says, we agree not all parts of your application are important. There are some parts that you use more than other parts. So like you might find in this Y application, you have a functionality where you need to update your profile picture. For example, you might set up your profile picture just once in a year or 6 months, and you'll read your message 5 times a day. You'll read your messages 5 times in a day. So you're better off compiling your the messages functionality before you compile the uh, profile picture functionality. So why should you waste time compiling something that you might not use, or battery when you're wasting your battery compiling something that you won't use? So you're able to save all that. You're able to save on space, save on able to save on space, able to save on battery life because you're downloading this, you're compiling these functionalities on demand. Your application is going to be faster. It's going to have consume power optimally and things like that. So how does it work? So once you install your app and you start using it, you're able to profile your usage. So you can have tools like Android runtime. I mean, not sorry, Firebase Insights. I've forgotten. Should be something Firebase Insights or something of the sort. So you you're able to understand. Uh, that is what you will use to view that information. But Android basically profiles that information, and looks at the functions that you use more often and the parts of the code base that you use quite a lot, and then that is saved. And then when your phone is idle, it uses that information to compile ahead of time on the parts that you use quite often. So the parts that you use quite often will load faster, and then the parts that you don't use quite often will load a bit slower. So yes, so the benefits of this is it saves your battery, saves your storage, uh, it focuses on what you use the most, and it launches the application faster. So I think
I have a question. Are you moving on the slides or on it's on my end or on just on slide one?
I'm still on slide one. I'm
Oh,
sorry. For my presentations, I have the slide doesn't have a lot of information. So what I'm saying is just this is just meant to guide me and you as the listener. So relax. Your screen is fine and your bandwidth is okay. But I'll rush. I think I've dwelled so much on Android runtime. So and then you have your native libraries. So your core libraries, basically, this is what provides your key functionality in the application and ensures that your applications are efficiently executed and so on and so forth. And then you have your application framework. So this is what connects your applications to your hardware abstraction layer and the other layers, the kernel and the hardware abstraction layer, which then pushes it to the kernel. So this is responsible for managing the resource management, the resources that you use, things like notifications, content providers. So content providers are things like when you log into an app and you set up enable biometrics to log into your app, the content provider is what is responsible for ensuring that the application is connected to the hardware abstraction layer so that you're able to use a biometrics to log into your favorite application. Uh, Things like camera permissions and so on and so forth are managed by the application framework. And then finally, you have the application layer. So the application layer, you have your end user applications. So your WhatsApp, your Maps, your Gmail, your Telegram, your X, your so on and so forth. So yes, I think basically that's it on Android system architecture. So the next step is Android Android storage. So Android storage. Android storage is basically where our data is stored, and they are very the Android storage for you to do. You can either get storage right the first step or get it wrong completely. So you really have to be very careful on what data you're storing and where exactly you're storing it. So with that being said, you can store your application. You can store data on your application on those storage mediums. So you have shared preferences. You have SQLite databases. Um, you have SQLite databases. You have Firebase databases. You have a Realm database. You have your internal and external storage, and you have the most exciting one, in my opinion, which is Keystore. So, okay, so what are shared preferences? Uh, Shared preferences is a form of storage that stores information in form of key value pairs. So this could be Boolean information or things that just have key values. So most of the information that is stored on shared preferences are things like themes. So when you're on your favorite application and you put um, dark mode, for example, so dark mode is information that is stored on shared preferences. So Um, so this is stored in form of a boolean. This is stored in form of boolean information. Hello, can you hear me? Hello.
Yes,
Yep,
I can hear you.
we can hear you.
Hello,
Okay.
Kiiru, we can.
Okay, sawa sawa. My network was misbehaving. So yes, so shared preferences are usually in plain text, so it's highly not recommended for you to have sensitive information stored on stored on stored on shared preferences. So you as an attacker, you as a security analyst, or as a red hat hacker, sorry, not a sorry, black hat hacker. Wow, white hat hacker. Sorry, my apologies. So you as a white hat hacker, I've been working on red hats because of the apologies. So you as a black hat hacker, a white hat hacker, you might need to store. You need to look for whether the application stores any sensitive information on shared preferences, and this could be maybe login status on an application. So if you're logged in, if a developer makes the mistake of storing that information on the shared preferences, so they're able to get that. And maybe if you have sensitive information like cookies, so you're able to extract cookies on shared preferences if they're stored as plain text, and so on and so forth. Yes, so that is shared preferences. The other one is SQL databases. So you have SQLite databases that you can either choose to encrypt them or decrypt them. So I think I'd like to believe that you have all interacted with SQL or SQL, depends on how you call it. So there are two approaches of doing this. So you might choose to encrypt the SQL databases. So this way you have a key, you encrypt it and you store the key on you either store it on an external key management system that you call the key, or you store it on your key store, which you're going to talk about in a few. And also you might choose to store, you have your SQL database in plain text. So the caveat of this is that this database can be, if you root a mobile phone, you're able to interact with an SQL database belonging to one app. So if this is in plain text, you're able to retrieve the information, able to extract the database, and you're able to view the information in that particular database. So if an application handles sensitive information, you need to ensure that if they're storing any data offline on your mobile phone, you need to ensure that the SQL database is encrypted. And then if it's not encrypted, just ensure that no sensitive information is stored on that particular database. Now, worth mentioning, Flutter has an implementation of a storage medium called Hive. So Hive makes it possible for you to store your information in which is lightweight, and it's very lightweight. So you're able to query your information very fast, and able to, the encryption process it's built with security by design. It has security by design principles put in place, so it's easy for you to encrypt that information, and able to encrypt and decrypt very fast compared to your normal SQL database. I haven't done the test, but that is what the documentation tells me, and from the developers I have talked to, they really recommend Hive. So if you have a Flutter application that you're protecting or you're building, you highly recommended to use Hive. The other one is Firebase databases. So Firebase is a program, is a product by Google. So one of the products they offer is a NoSQL database. So how this works is you have you have your you have your you have a store that you put information in JSON format, and you're able to retrieve that information. Able to retrieve that information. Able to retrieve that information from the internet. So the problem with Firebase databases is people don't know how to configure databases correctly. So as an analyst, you need to look at you need to ensure that this database is not publicly accessible. There are tools for that. I had a tool I had starred on my GitHub. Just give me a moment. It's called the tool that was starred is the tool that I starred is oh, unfortunately, it looks like I didn't start it, but I have it somewhere. Once I get it, I'll share it with you. I'll share it with Hope and I'll share it with you, or I'll share it during question time. So yes, you're able to view if you have an APK, you're able to scan an APK and get the Firebase link, and you're able to check if that particular database is exposed to the internet. And then you have your Realm. You have your Realm database, and then you have your internal and external storage. So your internal and external storage is basically your SD card and your internal storage. So by default, your applications store data on internal storage and only store on external storage unless you as the developer you define that. So the disadvantages of storing your application data on external storage is that you're able to view if I steal the SD card, or if someone steals your SD card, able to see information stored on that particular for those particular applications on your SD card. And that contributes, that's basically a data breach. And then Keystore is basically a store that allows you to store encrypted information on your mobile phone by default. So this is where your pins, and if you have encrypted your mobile phone, your decryption keys and other sensitive information is stored on your mobile phone. So if you're storing very sensitive information, you can have on your mobile application, you can have your application reach out to this particular API, and you're able to view that information. You're able to store that information there in encrypted format. So that means even if someone gets information of that information, you're not able to see that. And then the next thing we have today is on your cryptographic APIs. So you have your key components in Android cryptography, which include your security provider, your key store, and your keychain. So your security provider is basically used to ensure that to provide different cipher suites and different ciphers to encrypt your information. So once upon a time, we had something called Android OpenSSL that allowed you to transmit your information using SSL. You had some things like Bouncy Castle and so on and so forth. And then Keystone and Keychain, basically that is used to manage your life cycle for your keys, how your keys are generated, how they are used, they're stored, they're archived, and they're deleted. Basically, your whole key life cycle. So providers. So you have multiple providers to. There are multiple ways to interact with the security providers. So this is mostly through APIs. So you have the java.security class, your java.crypto class, your android.security class, your android.security.keystore class, and so on and so forth. So basically, when you're setting up, what you need to keep in mind when you're considering cryptographies and interacting with the Android cryptographic APIs is using things like Android keygen parameter spec to generate your keys. Also using ensuring that your security providers are updated, and so this is usually done mostly by the OEM, so your manufacturer, by just ensuring that you regularly update your phone's software. And if you're using legacy Android, they have this security provider called Conscript. So Conscript makes it possible for you to use modern security providers and on very old mobile phones and very old Android devices. So yes, so I think we have exhausted that on cryptographic APIs. So as we come to the end of this particular presentation, and I'm seeing the time is not on my end, I'm going to skirt through the OWASP mobile top 10 very fast. So the OWASP mobile top 10 was last updated last year, I think. Yes, it was last updated last year. So in the final release, they had the following vulnerabilities that made the cut. So the first one is improper credential usage. So basically, this is when threat actors and threat agents, black hat attackers, now I've used it correctly, exploits hard-coded credentials and ensure improper credential usage, such as not being able to such as not storing sensitive credentials, if you store them on your shared preferences and so on and so forth, able to perform different attacks, able to gain an unauthorized access to maybe other components, maybe your local database, or if it's an API key, you're able to, if you don't use that API key correctly and it's exposed, you're able to get that even using a static analysis scan. So that is improper credential usage. The second one is inadequate supply chain security. So this is by using very old packages and libraries on your Android application, because some of these libraries, if they're not patched, they are likely to have security vulnerabilities. So to prevent the first one, you are recommended to store if you're storing sensitive information, you either store it in an encrypted database or you store it on Keystore to prevent that information from being used from being accessed and used by unauthorized parties. So the second one, inadequate supply chain security, like I said, is using very old, not old, but outdated libraries, and also by injecting malicious code in your mobile applications database, or and also modifying a code during the build process. So this can be done through inside jobs or general or using third-party libraries, malicious third-party libraries. And if you have a bad vendor, like today I was listening to a podcast about how someone gained access to very top companies by hacking the security provider of that particular managed security provider of a certain organization, and they were able to gain access to 100 different organizations. So this can be, like I say, this can be done by inserting malicious code, not using exploiting vulnerabilities in third-party libraries, having vendors who are compromised. So this will lead to unauthorized access, data access or manipulation, and complete takeover of your mobile device or your mobile application, denial of service, and so on and so forth. So it's very difficult to detect this. And if this happens, you might get into financial losses, you might be sued, supply chain disruptions, and so on and so forth. So for this, like I said, there's also the insider threat angle. So for this, to prevent practices, I believe last week you had a session on DevSecOps. I hope the guy took you through static application security testing and doing code reviews and ensuring that your application is signed so that the application that is being used in the market can be tied back to you. Using validated third-party libraries. Don't just go get libraries from anywhere and everywhere. Yes, so insufficient. The third one is insufficient input-output insufficient authentication and authorization. So just like the first one, if you have an authorization flow being FLAW, if you have a flaw in your authentication flow, you're likely to, an attacker might use that, might take advantage of that particular flaw with an A to fake or bypass your authentication. So by maybe going straight to the backend server without necessarily interacting with your mobile app. So so basically that might lead to unauthorized access, unauthorized authentication or you're not authorized to maybe use a certain app if there are two different apps, one for like a customer and one for an admin. Yes, so that is one of the issues. So to prevent that can lead to, that's usually unauthorized access to data or information theft. So to prevent that, just sit down. Threats, I think that's usually, I'd like to be, I like saying that the medicine of that particular issue is usually just ensuring that you have a proper design. So take so much time sharpening your axe. So do your go back, architect it correctly, sit down, look at everything that can go wrong, do your threat modeling, manenos, and so on and so forth. And then also ensuring that your login information is not stored on your, if it's being stored locally, please ensure that it's encrypted. Yes, also ensuring that all authentication requests are handled by the server where possible, and so that you're not able to bypass that if that functionality is offline. And then there's that remember me functionality. So never ever store a user's password on a device if that remember me functionality is turned to be on. Yes. So, and also assume the authentication controls will always be bypassed by malicious users. So that way, you're able to come up with more robust practices. And then the next one is insufficient input and output validation. So this is usually just ensuring that your input is sanitized and validated, so that you avoid cases of injection attacks. This is your SQL injection, command injection, cross-site scripting, and so on and so forth. So for this, you just need to, if you're making any request to the databases, you sanitize your user input to remove arbitrary SQL or JavaScript inputs. In places where you require text of certain length, restricts the length to that particular to what you need. So if it's a phone number and it's in Kenya, 10 to 13 digits, and the only sign that should be allowed is the plus sign. So that way you're able to have your phone numbers and stuff like that. And then for output sanitization, ensuring that your output is also sanitized as well to prevent cases of cross-site scripting attacks, and also context-specific validation, probably for files and database queries, so to prevent cases of path traversal or malicious file uploads. And then data integrity checks, implementing different checks to to detect and prevent cases like unauthorized modification of data, or data data corruption. So that's the fifth one, and that's the fourth one. The fifth one is insecure communication. So this is basically using HTTP to communicate to the backend server. So mostly mobile apps are just there's always, for every mobile, not for every mobile application, for a good number of mobile applications, there's a backend server somewhere that stores your information. So, or rather, that relays your information to a certain database. So, so for that, you need to ensure that communication between your mobile phone and those backend remote servers is encrypted by default. So if that's not the case, a threat actor can be able to perform a man-in-the-middle attack. This should be your 8th week, so I'd like to believe you guys have done the man-in-the-middle practical, or you guys have done the Wireshark practicals at this particular point, so I will not dwell on that. And then the other one is inadequate privacy controls. So inadequate privacy controls, basically, this involves storing personally identifiable information, PII, such as names and addresses, credit card information, email, IP addresses, health information, religion, sexuality, and political opinions. Yes, so if this information is gotten, attacker can cause to one individual or a group of individuals. So this can be used to impersonate a victim, to misuse payment data, to blackmail people, harm. Maybe if you delete this data, you'll have caused some certain harm to this particular victim. Imagine if you dox this victim's health information. Imagine your health information just appearing somewhere online, and it's not a very good show. So that usually that comes with very big fines, especially in the UK or in the US. Also here, our fines are arguably big, but 5 million for a company sounds like slap on the wrist if you ask me, because they make a lot of money. But anyway, sorry for another day. So yes, so how do you prevent this particular case. Ensure that this particular issue, just ensure that storage is done in a very secure manner. So if it's sensitive information, always encrypt sensitive information being stored on your application, being persisted on a mobile device. So if there are cases where you need to, this is where data protection comes in. You're finding out if that data is really necessary for you to process it in the first place, masking that data, anonymization of data, uh, storing that data for a certain period of time, and so on and so forth. So I think I shall not dwell more on that. I see I have 5 minutes for you to ask your questions and to close. So insufficient binary protections. So that's when you don't this is when you don't uh this is when you don't what's it called? One of the reasons, one of the things that you don't do is, if you don't obfuscate your application, able to reverse engineer that particular application and modify that application to have malicious code, and you're able to redistribute that application again. I'll give you a story. Once upon a time, there was an application that I shall not name. Used to be a fitness application, very popular in the country in about 2018, 2019. So the thing with this application is that it it wasn't it there was a legit application and another application. So this other application had what's it called? It had malware into it, so it had code that did not belong to that particular application. So you'd have if you log in, if you log in using username and password for that, and store it somewhere else. So there were two applications that look the same, but one was legit and the other one was not legit. So yes, so that's the other way you can, like I said, that the first way you can do that is by reverse engineering, and the other way you can manipulate an application, the app binary, is by tampering with the code, which I think I have explained those two instances, because that's what happened. They reverse engineered the application, added their own code, and then supply the application. To prevent reverse engineering, ensure that your application is obfuscated. So there are very many obfuscation tools out there. I've forgotten the one I wanted to tell you about today. And then yes, so for redistribution, have integrity checks to verify that the application indeed is actually yours before that application is used, to prevent cases of redistribution and modifying your application's binaries. So yes, well, I took 3 minutes to explain that. The next one is security misconfiguration. So for security misconfiguration, you have your just improper configuration of things like permissions and controls and other security settings, which might lead to unauthorized access and vulnerabilities. Yes, so these threat agents it can be someone who has physical access to that particular device, or a malicious application that exploits security misconfigurations. So by this, you need to look at some of the settings that you have on your mobile app. Some of them have weak security settings to enable to trade off with, as a trade-off for a good user experience. So maybe you have unnecessary permissions enabled, which makes them vulnerable to attacks. Improper access controls, which can give users access to sensitive data or perform privileged actions. And then if you're using hashing, so implementing weak hashing algorithms can be exploited to gain access to sensitive information, amongst other things. So how do you prevent these particular issues? So ensure that your default configurations as for the application that is being developed is secure, and refrain from using hard-coded default credentials. And then there's insecure permissions. Avoid having you as a user avoid storing application files with very permissive permissions, like an application that can read from your storage completely and write to your storage completely. So I also like recommending regularly audit your permissions every once in a while. And then debugging. Anyway, I've seen things. So disabling debugging is basically just ensuring that your application is not, if a user downloads it, is not debuggable. If you're, yes, so you might see red screen of deaths if you're doing a Flutter application. Disabling backup on your Android device also goes a long way, ensuring that your sensitive data on that particular application is not stored on your device's backup. So yes, finally, insufficient cryptography. So for insufficient cryptography, this is basically attackers who target applications that have, they target cryptographic algorithms or implementations that are relatively don't meet certain security standards, such as DES, and so on and so forth. So this, if an application does not use sufficient encryption algorithms, it might lead to ability to decrypt some of this information which might be sensitive, and this can be used to conduct things like fraud, steal data, and so on and so forth. So to prevent this, there are different insufficient cryptography vulnerabilities, such as using weak encryption algorithms, like I have said, using insufficient key length. So you have an application that requires maybe 16 characters to create a key, and then if you have 8, then applications tend to pad the rest of the 8 characters, the deficit with spaces. So that is not very sufficient. Have a weak encryption or decryption key and it has spaces at the end, imagine now an attacker will be able to, if they're able to get that particular key, able to decrypt it, and the information, the rest that goes with it is not very nice. And then improper key management. So I think we've talked about this, storing very sensitive information on shared preferences and encrypted databases, exposed Firebase databases, and so on and so forth. And then unsecured storage of data encryption keys, and then not salting your hashed data if you're using hashes. Although hashes are hashing is not, anyway. Yes, so hashing is not encryption, but yes, so if you're using hashes, ensure that those hashes are salted if these hashes is very sensitive information, such as passwords. So yes, I think I have exhausted all of them, and I hope you have learned something, and this has pointed you to the right direction. Yes, so I'd like to open up the space for any questions.
Thank you so much, Kiiru. We have our first question from Emmanuel.
Oh, hi, Emmanuel.
Hi, man. Thank you for this session. It was quite insightful. and you broke down everything into something that is easy to understand. So props to you on that. Now, my question is not even a technical one, but rather it focuses more on the career side of things in terms of now application security and Android and all this stuff. So I actually went through one of your articles, and it was done where you're talking about the lessons you learned in cybersecurity. And I was fascinated by this point you had talked about, which was about mastery, where you suggested that it was best to specialize in a given niche as opposed to trying and knowing everything. So I guess now my question is, when you are pursuing application security and DevSecOps, how exactly did you brand yourself? Because one of the challenges that I've encountered since I'm actually doing something similar, or rather the exact path that you've taken, is, well, something like application security is kind of hybrid. So it has elements of development and it also has elements of security. And as you know, nowadays you are encouraged to brand yourself, to network all this stuff, and referrals come a long way. Now, take a scenario where you are trying to pursue application security. By the way, I'm just giving a background so that at least you can see where I'm coming from. Hopefully you will, yeah. So anyway, I was just presenting a scenario where now let us say you're pursuing application security. How do you brand yourself in such a way that you are referred to these kinds of roles that maybe you have gone through? Because the challenge is, maybe someone in the dev world might be like, but this guy is more into security, so I don't think I'll recommend them for a dev role. And in cybersecurity, guys might be like, this guy is more into dev stuff. You know, in cybersecurity, we are supposed to know a bit more stuff. So how exactly did you brand yourself in this kind of field?
Okay, that's a very good question. I'm actually flattered that you're one of my 5 readers. So, that particular opinion, that was the first one, and that one is usually taken. I'd like you to take that opinion with a pinch of salt, because that is just it's not golden advice, but that is what I will tell somebody. So fortunately or unfortunately, I had friends. I have friends who are more in the dev world. So even during my campus period, I hung around with devs, picked up a few things from the dev side, learned the fundamentals. So I think across campus, I think even my university projects were dev related. So, and there are things that I was very passionate about, and I learned that. So once I finished, I actually thought I wouldn't get a cybersecurity job. So what was left for me was to get into, what's it called? To get into development. So the internship I got in as a mobile developer for a month. A story for another day though. So I think you really need to look at what exactly it is that you want, because you will never learn everything in security. So if you start learning, you learn networks, yes, very good. You learn development, very good. You learn AI, even better. You learn so on and so forth. You learn very many things, machine learning. You've ever seen that meme of that Indian saying machine learning, big data, and so on and so forth? You're going to learn all those things. So you just need to call yourself, I'll translate this direct translation. You need to call yourself for a meeting and ask yourself, Emmanuel, what do I want? And for me, when I figured out this is what I want, because I mean, I've been staying with these guys, I enjoy development work. Yes, I wouldn't want to do it to get paid for it, because that is not what I'm really passionate about. So just sit down, make the decision, and then do what you need to do. Sit down, learn. I think at that time, I looked at, I got a, that time I had a Try Hack Me subscription, and I do a lot of boxes, so a lot of web boxes, and went through all those materials on Portswigger, and I read books on GraphQL API security, your normal API security, touched a lot of information, and now I'm touching a mobile application, applying for jobs. The caveat that comes with specializing over generalizing is jobs are not very many, and the cybersecurity market here has not really matured. So I think in banking, like I've only counted 3 banks that specialize, that have specialized cybersecurity roles, and one telco. So they're not, if you're looking for, but then if you specialize and you're very good at it, then if you're good at it and you're very passionate at it, the reward that you're going to get is going to be very high in the long run. So uh yes, so those are the caveats. So branding, I'm not very big on branding, if you ask me. So for me, I just do me, and I hope someday someone will look at me and also write some very good CVs when I apply for jobs, especially ones that uh, are very heavy on specialization. So for me, that's the decision I made. It's a very radical decision that has its own what's it called? Has its own drawbacks, especially when you're looking for jobs and growing, especially in such a market. But if you're aiming to get a remote job, which I believe all of us aim for, that pays in USD and you work at home, then specialization is where you need to be. Yes, branding. Hope Hope is very good at that. Uh,
Okay.
your
So we can have Enoch.
yeah. Yes, Enoch.
Good evening, Kiiru.
Yeah. Hi.
Now that you have touched on the Android and its security, is it possible you can elaborate on if I may ask, between the Android and the iOS, which one is the one that is usually hacked? Because for my case, I also use iOS, and I've never heard of maybe any attack on the iOS system. If you can elaborate on that.
Well, I am not that proficient on iOS and mobile security, and I wouldn't want to tell you a lie. So can I look into that and get back to you?
Okay.
Yeah.
Problem.
Any other one?
Okay. Yeah. Any other last person with a question? Okay, so Kiiru, if you could give your last remarks, and then I can bring the session to a close. Hello, Kiiru, are you on the call?
Yes, I'm still in the call.
Yeah, so I was saying if you could give your last remarks, because there seems to be no other questions relating the topic, and then I can bring the session to a close.
Okay, thank you very much, Hope. for this other opportunity. It's very nice doing this once in a while. It challenges me as well. And I think for this one was actually very different because I took a topic that I didn't know. And thank you very much for giving me adequate time to prepare. And I have learned a lot thanks to the 78 of you when I last saw, from when I last looked at the attendance when it peaked. So thank you very much to all of you, and I hope you have learned something because I have actually learned quite a bit, and yes, if you have any questions, please feel free to reach me, and if you need to learn, I've showed you what you need to learn. Your career prospects is you can look into product security roles, DevSecOps roles, mobile security analyst roles, and application security engineers and analysts, and so on and so forth. So your prospects are good if you learn this amongst other related topics. And yes, thank you. Have a good night and a good week, good remainder of the week ahead. And put on a sweater, please. It's very cold. Yeah, thank you.
Thank you. Thank you so much, Kiiru. We truly appreciate having you on the session. It's always a pleasure. Thank you so much for taking us through Android, just letting us know where to start off, what areas we should be looking at, the kind of opportunities that are open out there. I hope this is something those who find interest in it will pursue and can find it relatable to your careers. As always, I advise that if you see a topic and a mentor that really resonates with what you want to do, take the time to reach out. Let it not just be every Thursday session. Part of this mentorship program every Thursday is to make sure that you have a connection with a mentor in the industry, someone who can just guide you and give you direction if that is what you need. Yeah, so thank you so much, everyone, for a lovely evening. Something else I noted, you can check recordings are usually on the Cyber Shuja YouTube page, and we have a speaker who did like a practical view of Android security. I can't really remember his name, but you can just scroll through the YouTube recordings and take a step further. After you've had the introduction here, you can now go into maybe security tools that were utilized during that session. So that is something you can go ahead and check. If there are no other questions, comments, or suggestions, I'll go ahead and tell you guys good night and have a good rest of your night. See you next Thursday. Yes, I've seen a hand. Emmanuel?
Oh yes, thank you, Hope, for the class. I just wanted to know, I haven't. This was my first, but this was my first mentorship class that I attended. So I was wondering the previous one, so that I can go to that YouTube and try to follow up.
Okay, so just search Cyber Shuja on YouTube, and then once you click on the page, you'll see the recordings. All, I think, for the past 2 years, yeah, you'll be able to see them. Okay. Any other questions? Sawa sawa. Thank you, Kiiru, and good night, everyone. Bye. See you next Thursday.
Bye bye.
Right, see you.